So hello everyone. So today we are going to discuss about experiment 5, weighted wall hollow. So in the lab, you see there's a column. In this column, the water is allowed to come from the wall. Arrangement is like this: raised portion is put in the larger portion. So you put in water here. What will happen? Water will overflow and, and fill up from the wall. So from the wall, you can see water is coming down. Yes. And air is coming out. Yes. So what will happen? This is the air. And this is what. So aim of this is finding mass transfer coefficient for air water system using weighted wall walls. Correct? Title is weighted wall. Correct? So what will happen is the interaction of air and water, the water will get added to the air. Correct? What will happen? So here you can have dry bulb temperature, wet bulb temperature. In this corner you have dry bulb temperature, wet bulb temperature. So dry bulb is a normal temperature and wet bulb is a bulb with weighted cotton. So this basically talks about saturation temperature. Yes. So because of the variation of water vapor in air, there is a variation of T1, T2, T3, T4. Correct? This would be the variation. And based on this, we can find out the amount of water getting evaporated into air. How do you find out? You find out from psychrometric chart. This chart is like this. From psychrometric chart, like this. You can see there are straight lines which are variable line. This is variable temperature. And you can say another set of lines which are inclined line like this, which are with bulb temperature. Then have in line like this, which are relative humidity. On this side, we have humidity line. So what you do, you start with wet bulb, come to a point until it meets dry bulb. Here's the point. And whatever this line is, the blue line will be your relative humidity value. If you go on right hand side, this would be your humidity. Correct? So based on this, we have to find out how much water is evaporated. So what is the formula? Na equals kg, want to do in partial pressure, Pa1 minus Pa2. Yes. Now first I have to find out Na. So I have here flow rate of air. So batch B1, B2 I have given. For batch B3, flow rate is your roll number into 5.8. That is flow rate in liter per pound. This is air flow rate. Take your roll number multiplied 5.8 will give you liter per hour. This is a unique value so that everybody has a different calculation. Yes, there's no repeat. This is the flow rate, you know, air. Now, how do you know how much water is added? So, Na is kilomole per meter square per second. Yes. So, what is relative humidity at point 1, bottom? Relative humidity 2 at top. So, what is relative humidity? It is partial pressure divided by vapor pressure. Partial pressure divided by vapor pressure. So you can find out vapor pressure. How do you find out vapor pressure? So you have DBT, dry bulb temperature 1, dry bulb temperature 2, bottom, top. So we have Antoine equation for water, which will give you ln P equal to A minus B upon T plus C. So this will give you vapor pressure. So use relative humidity which was obtained from DBT and WBT from psychometric chart, correct? Find out PA1, PA2. Once it's done, to find out amount of, so this is PA1, PA2 which is required. So PA1, PA2 is the next required amount of water. So you have to find out humidity. What is humidity? Kg of water vapor upon kg of dry air. Right? That's the humidity. So you can convert your air. Here you have in LPH, take density of air equal to 1.2 kg per meter cube. Convert LPF into kg. That's a kg of dry air. So it will give kg of water vapor in inlet air, correct? Say M1. Similarly, you can find out kg of water vapor in outlet air, M2. Clear? Because you'll get humidity 1, humidity 2, bottom, top. So this will give you M2 is water vapor coming in, going out. This is coming in. Yes. So this is kg of water vapor per kg of dry air into kg of dry air, which was a flow rate, which is roll number into 5.8. Convert this with a density 1.2 into, so this will give total amount of water vapor added to the system. Convert that into, this we got in kg of water vapor divided by molecular weight of water, which is 80. This will give you kilomole of water vapor added to system divided by meter square. What is meter square? Take diameter equal to uh, 8 centimeter, and height you can take 1.5 meter. So it's inside. There's only I'm giving for B3. For B1, B2, we have taken exact value, or you can take an exact value of a setup and use it. So this will give you surface area. This area is surface area. Pi r square h, correct? Or 2 pi r. Your surface area. 2 pi r l or h. Correct? This is surface area, which will be used, and you can take operation of 1 hour. So by 3600 second. So this is going to give you Na. So we got Na in kilomole per meter square second into, we got Pa1 minus Pa2, we'll get this kg. Correct? So Na is known, Pa1, Pa2 is known, so we'll get kg. Clear now? So this is the way we are going to Find out kgs. That's our objective. Unit of kg, kilomole per meter square for atmosphere. That is an objective. Find out mass transfer coefficient. Now let's move to the next one. Line number 6. Title: Absorption of gas in liquid with chemical reaction. A, finding percent absorption of CO2 in NaOH. Again, we have column. With packing. Is filled with packing. Filled up. So CO2 is going, CO2 plus air mixture is going up. And we have NaOH coming down. 11, it will react. So we have reaction NaOH plus CO2 going to give you Na2CO3 plus H2O. Balance out your 2, correct? Use this reaction and find out how much CO2 is absorbed. That's a simple calculation. Now, how do you find out? Let's just start with some concentration of NaOH. By the time it comes down, the NaOH comes down, and take out the sample and to find out what is a remaining NaOH concentration. Because part of NaOH is used to absorb CO2. So how do you do it? You titrate this. Yes. You titrate this with HCl. Take one normal HCl and find out how much is the NaOH concentration, which is, so this will give you, so we know this is N1 and bottom will get N2. What is N1? Mole per liter, equivalent to kilomole per meter cube. So this is going to basically C1, C2. Right. If you know flow rate of NaOH, you'll be able to find out how much NaOH is absorbed. Yes. For batch 3, B1, B2, I have given the values. For batch 3, NaOH flow rate is your roll number into 1.76 liter per hour. That's the flow rate. So we have C1 higher minus C2, correct? Kilomole per meter cube. Yes. NaOH coming in, going out. This difference is going to be into flow rate of NaOH. Convert that to liter per meter cube. So this will give you kilomole of NaOH absorbed. That's it. So now we have to find out how much CO2 is absorbed. So we can take, we have a mixture of CO2 plus air coming in. So we can take flow rate of CO2. So batch 1 and 2 I have given, batch B3. Flow rate of CO2 is your roll number into 7.8 liter per hour, and take air flow rate CO2 flow rate divided by 2.12 the flow rate of air. If not 2.12, the air flow rate should be higher than CO2 0.1. 0.4. Okay. CO2 flow rate divided by 0.42 is higher flow rate of air. So we know now NaOH plus CO2 are going to give Na2CO3 plus H2. It is twice. So 2 mole of, we know how many moles of NaOH are reacted. So mole of CO2 absorbed would be equal to half of mole of NaOH. Right? This will give you mole of CO2. We know initial mole of CO2 in a mixture. How is that? You have liter per hour. Convert that into meter cube. Multiply with density of CO2, which will give you kg, divided by molecular weight, to give you kilomole. So we know kilomole of CO2 coming in, and we know mole of CO2 absorbed. So percentage CO2 absorption equal to CO2 initial minus CO2 final divided by CO2 initial. So this is CO2 absorbed, right? Into. So this will give amount of CO2 absorbed. This one we have to find out. So everything is given. So accordingly you can find out. That's the 2 experiment. Thank you.